So we're going to talk a little bit about base-5 numbers. And we saw a number of different number systems, maybe no pun intended. Right, we talked about sort of Mayan and Babylonian, Egyptian, and what we're going to do is we're going to do base-5, which again, remember, ours is a base 10 number system that we typically use called the Arabic system. The decimal DECI is short for 10, so that's again why it's base 10. We're going to talk about stuff in base-5. Okay, it's seemingly, there's a couple of things that you might be thinking of. One is, good God, why? And that's a perfectly good reason. I'm going to go through that maybe a little bit at the end, and in further videos which we'll talk about. And you know, this may be like just a head scratcher, like, if you've got a good sense of money, which I think probably most of us do, it's not too bad to think about. So let me just dive in and show a little bit about what this is. So I'm going to grab, let's say, the number 64, and I want to write this in base-5. So how do I do this? Well, what I'm going to think of, right, I'm going to have pennies, nickels, and quarters right now. And what I want to do is just how many of each of those numbers, or each of those coins, does it take to make 64, right? And so first of all, if you think, okay, I've got two 25s, right, that makes 50 cents, and I've got 14 left over, right? I'm going to do 64 minus 2 times 25 has 14 left over. This is hopefully fairly straightforward to think of, is how do I do this? There are two nickels there, whoops, two nickels and 4 pennies. 1, 2, 3. Okay, so I can, right, if I had a pile of coins here, how do I come up with 64 using only these? I'm not going to use the dimes or a 50-cent piece or anything like that. Using only these 3 coins, I come up with this. So what does this mean? Well, 64 I can represent with 2 quarters, 2 nickels, and 4 pennies. So what we're going to say is 64, this is in decimal, is 2, 2, 4, and this is base-5. And here's how we distinguish this. This number, it just looks like a regular number. It's a decimal number. If I write it with a subscript 5, it's in base-5. So that means I've got 2 quarters, 2 nickels, and 4 pennies. Okay. Let's look at, let me look at one more example, and then we'll also reverse. Okay. So I am going to jump up a little bit and do a 416. Okay. Now, if you think about this, how many quarters do I need for this? Well, I need $4 worth, right? 4 quarters and $1, this would be 16 quarters. Okay, so here's what we're going to do now. In base 10, really we use the numbers only between the digits, between 0 and 9, right? Once we reach 9, so if we're just counting up to 9, what do? 10 is represented by 110, and 0 ones is the number 10, right? And so we don't have a special, what's called a glyph, right? A special character for 10. right? Sometimes in like the Mayan system we do, or we write it with other glyphs, but not in the Arabic system, right? So base-5, let's just think about this a little bit more. Base-5, use only the digits 0, 1, 2, 3, 4. Okay, so the last example, which we did 2, 2, 4, made sense. Okay, so here's what we're going to do. Now, for this number, I need 16 quarters. Well, that doesn't fit there. So I'm going to write, I'm going to come up with another coin. It's probably not one you have in your pocket, but you can really imagine that there is such a thing. You know, maybe I had some coin-like things that were blue, okay? If this needs a name, sometimes I call it a fiftoon, which is maybe a little bit complicated, but there's coins that are called doubloons, type of things, and this has to do with base-5, so maybe it's a fiftoon. I don't think there's a terminology for this, but let's call that a fiftoon, right? Okay, so we're going to take this, and we want to try to write it with these things. Okay, so here's what I'm thinking of, right? So, 1 fiftoon, right, is 125. 2 fiftoons is another 125, so 250. 3 fiftoons is another 375, right? And 4 of them would be 500. Okay. So now this, I need 3 of these guys. Right. To get enough. Right? Okay. And so now, how much is left after I've like cashed out 125s? There's 25 and there's 16. A total of 41. I just did a little mental math there. We'll do a lot of that, right? I did 16. This is 25 lower than 400, so it's plus 25. Easier to think about. Is 41. Right? 41 is how many quarters? Well, just 1 quarter. Right? And then I have 41 minus 25 is 16, which is 1, 2, 3 nickels and a penny. So 4 16 in base 10 are 3 125s, 1 quarter, 3 nickels, 1 penny, right? Subscript 5, so we know it's base 5. Okay. Interesting. All right. Now, here's what I also want to do is I want to do the reverse, which I think is actually quite easy, quite a bit easier. Let's do 304 in base 5 and then convert to decimal. Okay. So what does this mean? Right? So these are 1s, 5s, 25s. So I have 3 times 25. And say no nickels, but I'll write it as 0 times 5. And 4 pennies. 75 plus 4 is 79. So 304 equals 79 in 5, base 5, equals 79. And again, I don't need to write anything on this because it's decimal. And let's do one more. Go green this time. 1, 2, 4, 3, base 5. Okay, so ones, nickels, quarters, 15s. Two quarters, 4 nickels, 3 pennies. 125. That's 50. There's 20 and 3, right? There's 70. 195 plus 3, 198. Okay. So this 198. No subscript means base 10. All right. Now, let me talk a little bit about where this is going. The reason I do this is we're going to do a bunch of operations. So we're going to do addition, subtraction, multiplication, and division using base 5. And basically what it does is it pushes us a little bit out of our comfort zone and really get us thinking about why we do certain things. So we'll talk about the column algorithm for multiplication, subtraction, division, and addition, and then long division with all of these numbers, and really go in and just say, okay, what is it that I'm actually doing with all of these things? I'm also going to come back to these coin models with this and tie that all together. I think a good understanding of this, going back to decimal, goes, I really understand why I'm doing this kind of thing, which is really the key when you're trying to teach it. You've got to understand things at such a deep level. So I think this really not, the reason for this is not that you're going to go out and do base 5 addition and multiplication all over the place as teachers. You're going to do regular base 10 versions of these things, but it firms up what we're doing in decimal. Okay, so that's basically a preliminary introduction to base 5, and we will see more of that later.